soft body armor, and Kevlar. DuPont chemist Stephanie Kwolek discovered the fiber that would eventually become Kevlar in 1965, stumbling onto the breakthrough entirely by accident while trying to develop a stronger material for reinforcing vehicle tires rather than anything remotely related to stopping bullets or protecting anyone from gunfire at all. Kwolek noticed her experimental polymer solution behaved strangely, appearing unusually thin and cloudy rather than the thick, honey-like consistency her colleagues expected. And when a lab technician initially refused to spin the strange liquid into fiber, assuming it was simply contaminated with foreign particles, Kwolek personally convinced him to try anyway, despite his genuine reluctance. The resulting fiber tested 5 times stronger than steel by weight while remaining genuinely lightweight and flexible, and the National Institute of Justice specifically pushed to adapt that same material into wearable police body armor throughout the early 1970s. Entrepreneur Richard Davis founded Second Chance Body Armor in 1970 and famously marketed his own concealable Kevlar vest by shooting himself on camera roughly 200 times over the following decades. A genuinely dramatic sales pitch that helped convince skeptical police departments nationwide that soft body armor could reliably save an officer's life. Davis reportedly staged many of these demonstrations directly for individual police chiefs and department procurement officers, understanding that watching a vest actually stop a real bullet fired at genuinely close range convinced far more skeptical buyers than any written test report or laboratory data ever could on its own. Level 2. A soft armor. Level 2A represents the lightest, most concealable category of soft body armor the National Institute of Justice formally tests and certifies. Built specifically to stop lower velocity handgun rounds like standard pressure 9mm and .40 caliber ammunition fired from a typical service or concealed carry pistol at realistic engagement distances. That reduced protection threshold lets manufacturers build genuinely thinner, more flexible panels using fewer layers of woven aramid fiber, making Level 2A vests the most comfortable and easiest to conceal under ordinary clothing for extended daily wear across an entire working shift or day out in public. Plainclothes detectives, off-duty officers, and civilian buyers prioritizing genuine day-to-day concealment specifically choose Level 2A over higher-rated alternatives. Accepting a somewhat narrower range of defeated threats in exchange for a vest thin and light enough to comfortably forget you're even wearing after a few hours of continuous daily use. That trade-off between protection level and comfort defines the entire soft armor category more than almost any other single design consideration, since a vest genuinely too bulky or hot to wear consistently provides considerably less real-world protection than a lighter vest an officer or civilian actually keeps on their body every single day. Studies conducted by police departments and body armor manufacturers alike have consistently found that officers issued heavier, less comfortable vests are genuinely more likely to leave that same armor sitting in a locker or patrol car rather than actually wearing it during a routine shift. A real-world compliance problem that a lighter Level 2A vest specifically helps solve. Level 3. A soft armor. Level 3A sits at the very top of the soft armor category, representing the maximum protection. A flexible, non-rigid vest built from woven aramid or ultra-high molecular weight polyethylene fiber can realistically achieve without transitioning into rigid hardplate territory entirely, and abandoning the concealability that makes soft armor genuinely practical for daily wear in the first place. That top soft armor rating certifies a vest to stop the vast majority of handgun threats a law enforcement officer or civilian might realistically encounter, including higher velocity Magnum handgun rounds that a lower-rated Level 2A vest genuinely cannot reliably defeat under real-world testing conditions. Most standard-issue police duty vests worn across American law enforcement agencies today carry this exact Level 3A rating specifically because it represents the practical ceiling of what soft, concealable armor can accomplish, covering essentially every realistic handgun threat without forcing an officer into the dramatically heavier, bulkier hard plates rifle-rated protection actually requires for genuine field use. That widespread standardization across nearly every American police department also simplifies procurement and training considerably, since officers moving between agencies or receiving replacement vests generally already understand exactly what level of protection their new equipment provides without needing extensive additional briefing. Security professionals and civilian buyers focused specifically on realistic home defense or personal protection scenarios, rather than dedicated rifle threats, commonly settle on Level 3A as their own practical baseline too, since it offers the broadest handgun protection available before a buyer has to commit to carrying genuinely heavy rigid plates every single day. That widespread Level 3 adoption across both law enforcement and civilian markets alike genuinely reflects a broader statistical reality too, since handgun rounds still represent the overwhelming majority of actual firearm threats officers and civilians realistically encounter compared to the far rarer scenario of facing genuine rifle fire. Level 3 Hard Plate. Level 3 marks the entry point into genuine rifle-rated hard armor, requiring a plate to stop 6 separate rounds of 7.62 by 51mm NATO ammunition, the standard full metal jacket when fired from AR-10 pattern rifles and similar battle rifles chambered in that same cartridge across a genuinely wide range of tested impact locations spread across the plate's overall surface area. Crossing from soft armor into Level 3 hard plate territory means abandoning flexible woven fiber entirely in favor of a genuinely rigid panel built from steel, ceramic composite, or polyethylene, each material offering a different balance of weight, durability, and cost that a buyer has to weigh against their own specific priorities and realistic threat environment. A notable gap exists between Level 3's official rating and certain common rifle threats too, since some standard Level 3 plates can actually be defeated by M855, green-tip ammunition fired at close range from a longer barrel, leading manufacturers to market an unofficial Level 3 Plus designation specifically for plates tested against that exact threat, despite the NIJ itself never formally recognizing that intermediate category as an official published standard. Buyers genuinely need to research each specific plate's own independent test data carefully before relying on that unofficial marketing label, since the exact threats a given Level 3 Plus plate actually defeats can vary meaningfully between different manufacturers using that same informal designation. Law enforcement tactical teams and military units facing realistic rifle threats overwhelmingly default to Level 3 as their genuine baseline standard. Balancing meaningful rifle protection against the real weight and mobility cost, every hard plate necessarily adds to a loadout already burdened with weapons, ammunition, and other essential tactical equipment. That weight consideration genuinely matters more than casual observers might assume too, since a full set of Level 3 plates worn front and back can easily add 10 pounds or more to an officer's or soldier's total carried load, a meaningful physical burden across an entire extended patrol or operation. If you've ever wondered why a rifle-rated plate can fail against a specific green-tip round, that's the kind of gap between marketing and testing this channel keeps digging into. Subscribe if you want the next one explained the same way. Level 4 Hard Plate. Level 4 represents the single highest civilian and law enforcement body armor rating the National Institute of Justice currently certifies, requiring a plate to stop a genuine armor-piercing .30-06 round with a hardened steel core, the exact category of ammunition specifically designed to defeat lesser rifle-rated protection entirely that a soldier or officer might otherwise wrongly assume already offers adequate protection against that same threat. That armor-piercing threat standard makes Level 4 meaningfully different from Level 3 in a way that goes beyond simple raw stopping power too, since defeating a hardened steel penetrator core demands genuinely different plate construction and material science than merely stopping a standard lead core rifle round traveling at comparable velocity ever requires from the exact same panel. Steel plates have essentially disappeared from the Level 4 market entirely in recent years, since achieving that armor-piercing rating in steel alone would require a plate so thick and heavy, potentially 12 to 15 pounds per panel, that virtually no manufacturer still bothers producing one, leaving ceramic and polyethylene composite construction to dominate the entire category instead, across nearly every major manufacturer currently selling Level 4 rated protection. That near-total shift away from steel at the highest protection tier genuinely illustrates how far material science has advanced since body armor's earliest days, when steel plating represented essentially the only realistic option available to anyone seeking genuine protection against rifle fire of any kind. Military and tactical operators facing realistic armor-piercing threats specifically choose Level 4 despite its added weight and cost, precisely because it remains the only certified rating actually designed and tested to defeat that exact category of ammunition, rather than simply performing well against more common standard ball rounds fired from an ordinary rifle. The National Institute of Justice currently caps its own formal rating system at Level 4 entirely too, meaning any protection claiming to exceed that standard, sometimes informally marketed towards specialized military applications, falls outside the NIJ's own official testing and certification framework altogether. Ceramic plate. A ceramic hard plate builds its primary protective layer from a hardened ceramic material, typically boron carbide or aluminum oxide, specifically chosen because that same brittle hardness that makes ceramic a poor choice for nearly every other engineering application becomes a genuine advantage against an incoming bullet traveling at genuinely high velocity toward the plate, his own strike face. When a projectile strikes the ceramic strike face, the material deliberately shatters and fractures around the point of impact, absorbing and dispersing an enormous amount of kinetic energy in that exact shattering process, before a backing layer of polyethylene fiber catches whatever fragments and remaining energy the ceramic itself couldn't fully stop on its own during that same violent impact sequence. That shattering mechanism means ceramic plates genuinely don't handle repeated hits to the exact same location nearly as well as steel or polyethylene alternatives. Since each impact leaves a permanently damaged, weakened zone, the ceramic can never structurally recover from afterward, regardless of how much time passes between that initial strike and any follow-up shot landing nearby. Manufacturers arrange individual ceramic tiles in a mosaic pattern across the plate's overall surface, rather than using one single continuous slab too. A deliberate design choice that contains any given impact's damage to just the immediate tiles involved, rather than letting a single hit crack the entire plate straight across its whole surface area at once. Ceramic plates do offer one genuine advantage soldiers and officers specifically value despite that multi-hit limitation though, since ceramic construction avoids the dangerous metal fragmentation, called spalling, that a steel plate can throw off the moment a bullet strikes its surface at a sharp angle during a real engagement. Steel plate. A steel hard plate relies on nothing more exotic than hardened steel alloy to stop an incoming round, offering genuinely exceptional multi-hit durability and the lowest cost per plate of any hard armor material currently on the market for buyers specifically prioritizing budget and raw ruggedness over reduced weight or comfort during extended wear. Unlike a ceramic plate that permanently weakens at each individual impact point, steel can absorb repeated hits across a much wider area of the exact same panel without losing meaningful structural integrity. A genuine advantage for anyone specifically expecting a sustained engagement rather than a single isolated shot fired from a considerable distance. That same hardness creates steel's single biggest safety drawback though, since a bullet striking a steel plate can fragment and spray dangerous metal shrapnel, called spall, both outward and sometimes back toward the wearer's own exposed limbs, neck, or face. A genuine risk manufacturers address by bonding a dedicated, spall-catching liner directly onto the plate's outer surface before it ever reaches an end customer. That added liner genuinely became a standard industry practice rather than an optional accessory once departments and individual buyers alike better understood exactly how dangerous unmitigated steel spall could prove, even when the underlying plate itself successfully stopped the actual incoming round entirely. Steel plates have grown considerably less common at the very top end of the market, specifically because reaching Level 4's armor-piercing rating in steel alone demands a genuinely impractical thickness and weight, leaving steel construction most common today in the mid-tier Level 3 category rather than at the industry's highest certified protection level. Budget-conscious buyers and training organizations specifically favor steel plates for practice and drilling purposes too, since a genuine steel plate can survive the exact same repeated impacts across countless training sessions that would quickly destroy a considerably more expensive ceramic panel reserved for actual field deployment instead of routine practice use. Polyethylene plate. A polyethylene hard plate builds its core from ultra-high molecular weight polyethylene fiber, commonly abbreviated UHMWPE, pressed and layered under intense heat and pressure into a rigid panel considerably lighter than either a comparable steel or ceramic alternative built to the exact same certified protection level. That significant weight advantage, often several pounds lighter per plate than steel construction rated to the exact same protection level, has made polyethylene increasingly popular among buyers who need to wear rifle-rated protection for genuinely extended periods without the accumulated fatigue heavier materials eventually cause across an entire long-duty shift or extended field operation. Polyethylene also handles multiple impacts considerably more gracefully than a brittle ceramic plate does, and unlike steel, it produces essentially no dangerous metal spall when struck, combining two of the biggest advantages steel and ceramic each offer individually without either material's most significant drawback holding it back in a real-world deployment scenario. That combination of genuine multi-hit capability and complete freedom from dangerous fragmentation has made polyethylene an increasingly common choice across both military and civilian markets alike, even as its higher production cost compared to simple steel construction keeps it from fully replacing the older material at every single price point currently available. Manufacturers increasingly pair a thin ceramic strike face with a thicker polyethylene backing layer specifically to capture the genuine strengths of both materials at once, using the ceramic to shatter and slow an incoming armor-piercing round on initial impact while the polyethylene core absorbs and catches whatever fragments and remaining energy the ceramic strike face itself couldn't fully stop. That hybrid ceramic and polyethylene construction has become genuinely common across the modern armor market, specifically because it lets manufacturers hit a level 4 armor-piercing rating at a meaningfully lower total weight than either material could realistically achieve entirely on its own without that same complementary layering approach.